we're asked to determine how many of the particles are polar. To do that, we would have to draw the Lewis structure for each of the 5, look at the electronegativity, and from there, draw the dipoles and determine the net dipole charge. So, starting with SO3, the molecule will look like this. So 3 oxygens, 1 sulfur, and it has a total of 24 electrons. So we start with the outside first. Okay, but there will be a double bond because these are too many electrons. Alright, and so now we have to determine the electronegativity to see the partial charge. So oxygen is more electronegative than sulfur, so they all are partially negative, with sulfur being partially positive. So we start with, to draw the dipoles, you go from the least electronegative to the larger for each set of molecules. Now that we have the dipoles, we need to determine net dipole, and that will tell us if it's polar or nonpolar. So the structure is trigonal planar, meaning that it's all on the same plane. And so all these charges, since they're all the same, all these three arrows, they cancel each other out, making the molecule non-polar. There are no net dipoles. Alright, now with OF2, same thing. Draw the Lewis structure. Put all the electrons on the outsides first. There are 20 electrons. Then the inside. And F is more electronegative, so it is partially negative, with oxygen being partially positive. So it goes from the smaller electronegative to the larger, tail end on the small side. Those are our dipoles. But the molecular geometry is bent, so that means if we were to draw it how it would actually look, with oxygen, fluorine being on the ends, see that it's bent and the charges go this way, leaving a net dipole charge going down. So since there is a net dipole charge, it is polar. Now BeCl2. So we draw it out. BeCl. There are 16 electrons, so start with the outside first. Okay. Now Cl is more electronegative, so it's slightly negative charge, Be being slightly positive. And so you go from the smaller to the bigger, each set, and the molecular geometry is linear. So that means that both of these cancel each other out, leaving no net dipole, which makes it non-polar. Now, CCl4, C is in the middle with the Cl's on each side. And there are 32 electrons. So outside first. There are all the electrons accounted for, and Cl is more electronegative than C, so it is slightly negative, with C being slightly positive. And now we need to draw the dipoles for each pair. So from here to here goes this way, here to here goes this way, here to here it'll go this way, here to here will go this way. So the molecular geometry is a tetrahedral that would look something like this, with this Cl being on a different, being behind the rest, which means that all of these would cancel each other out, making it so there would be no net dipole, making it non-polar. That last one is O3. So this would be like this, and O would have to make a double bond with one of them, because there are 18 electrons. 16. Okay, so the outside would be more electronegative in ozone, and this would leave, since this one's negative, the other side has to be positive. So the middle one is positive while the outer two are negative. And so the dipoles would go like this, smallest electronegativity to the biggest, same way here, and the molecular geometry is bent. So to draw it out, it would look like this. The dipoles going this way, and so the net dipole would be going down. So since there is a net dipole, then it is polar. And some of the common mistakes would be to here draw it out to where it would have too many bonds because it could be resonance structure, or mistakenly not know the electronegativities and having Lee's wrong and the dipoles wrong. But the most common mistake would be not knowing the molecular geometry and looking at that. Since these two look very similar but have different molecular geometry, one is polar and one is non-polar.